For problem 23, we know that B is 7 and angle A is 55. I'm going to solve for my angles first. To solve for my angles, I know that A is 55, B, I don't know, C is 90. Now I know that all three angles should add up to 180. So I'm going to minus the 90 and I'm going to minus the 55 to get 35 degrees for my missing angle. Now my goal is to find my missing sides. So I'm going to label O, H, and A. Now I'm going to use 7 every time because it's given. If I solve for side, let's solve for side A first. Side A, this missing piece here. That means I'm using these two letters. I'm using the opposite side and the adjacent side. That is tangent of 55, which equals O over the 7. So A over 7. To get rid of the denominator, I times by 7 on both sides. And A is equal to 7 tangent 55 equals 9.9 rounds up to 10. Now I can solve for B. Oh wait, solve for side, I already know B. I need to find C. So I'm using these two sides, A and H, mean cosine of 55 equals A over that side times by C. They cancel out. These two I can't enter into the calculator, so I need to divide by cosine of 55. Cancels out, and C equals 7 divided by cosine of 55. 12.2 stays 12. A is equal to 10. B is equal to 7. C is equal to 12. Problem 24. I know that side A is 12, and I know that angle A is 53. I'm going to solve for my angles first. A is 53, B I don't know, C is 90. 180 minus 53 minus 90 is 37 degrees. Now I'm going to solve for the sides, so I'm going to label O, H, and A, adjacent. Solve for side C. I'm going to solve for side C first. That means I'm using O and H. Sine of 53 equals the whatever number is with O and whatever letter is with the H. Times by the denominator. Divide by sine of 53. Those cancel out, and C equals 12 divided by sine of 53, 15. solve for side B. That means I'm using O and A. That's tangent O and whatever letters with the A. Get rid of the denominator. I cannot enter this into my calculator, so I need to get B by itself still. Divide by tangent. And B equals 12 divided by tangent of 53. 9. So side A equals 12. B equals 9. And C equals 15. Now for the word problems. We have a 15-foot ladder is placed against a wall. Here's my ladder. Here's the wall. Here's the ground. The ladder is 15 feet. The ladder is on level ground at an angle of 70.5 degrees to the horizontal. Horizontal is left to right, so this 70 degrees goes on this angle right here where the ladder touches the ground. This is a right angle, that's the angle the wall makes with the ground. About how far up the wall does the top of the ladder, would the top of the ladder be located? So I want to find how far up the wall the ladder will hit. I'm going to use trig to solve this equation. Here's my angle. I know that this is the opposite side and this is the hypotenuse. You're using so. Sine of 70.5 equals O over H times by the denominator to get x by itself, and x is equal to 15 sine of 70.5. 14.1. And the measurement for this should be, I'm going to rewrite it, 14.1. The measurement was in feet. .1 feet up the wall. 26. Sketch a rectangle. There's my rectangle. With side lengths 5, 5, and 10. 10 would be the longest side. Okay. Sketch one diagonal. Find the acute angle formed by the diagonal and a long side. So the angle formed by the diagonal and the long side would be this angle, or I could even choose, here's the diagonal, here's the long side, that angle. You could choose which one you want to do. Now the trig function would be opposite, there's no hypotenuse labeled, adjacent. TOA, tangent of x equals O over A. Do the inverse to get the tangent to leave the x, and that equals second tangent, 5 divided by 10 equals 26.5, rounds up to 27 degrees because it is an angle that we just found. 27, a bluebird is on a 30-meter tall flagpole. Here's the flagpole. It spots a worm on the ground. Here's the worm. At an angle of depression means the bird is looking down at the worm. That angle right here is going to be 25 degrees. How far away from the base of the flagpole is the worm? So they want to know how far the worm is from the base of the pole. If I create a right triangle, I know that this length has to match the height of the flagpole. And if this base is x, I know that this base for my other triangle has to be x as well. Now I can solve using this triangle. Opposite, no hypotenuse, adjacent. Tangent of 25 equals O over A. I want to get x, solve for x, so I get rid of the denominator. Now I can't enter that in, so I need to divide by tangent. And x equals 30. 30 divided by tangent of 25 equals 64.3, and my measurement is in meters. Problem 28. Explain why and when we use the inverse of sine, cosine, and tangent. So when do we use the inverse? I want you to answer that on your own. If you need to, look back through the videos and see where we use those.